Hello guys, welcome back to the channel Mathemagix JEE.
This is a famous question on theory of equations that was asked in JEE Main 2024. You may have seen the solution of this question in many other channels, but here is a conceptual part of this question that I want to explain in this video. Let us first talk about how to solve this question. Here it says, let x1, x2, x3 and x4 be the roots of this equation, this, and we are asked to find the value of this expression. So the main idea of finding the value of this expression is to use complex numbers. This is the main idea of this question. Now, how to do this? We have to simply write this equation, which is 4x to the power 4 plus 8x cube minus 17x square minus 12x plus 9 equal to 0 as product form. So this is a polynomial which can be represented as the product of some linear factors times the leading coefficient. In this case, the leading coefficient is 4. So we can write this polynomial as 4 times, which is the leading coefficient, then x minus x1, then x minus x2, then x minus x3, then x minus x4. Now we have to simply put x equal to 2 iota, where this iota is root over minus 1. If we put this equation becomes, we put x equal to 2 iota both sides. So this becomes 4 into 2 to the power 4 times iota to the power 4 is 1 plus 8 times 2 cube, and then iota cube is minus iota, then minus 17 times 2 I square. So that means 2 to the power 2 times I square is minus 1. Then minus 12 times 2 iota plus 9 equal to, then 4 times 2 iota minus x1, then 2 iota minus x2, then 2 iota minus x3, then 2 iota minus x4. Or we can write this as 4 times x1 minus 2 iota, then x2 minus 2 iota, then x3 minus 2 iota, and x4 minus 2 iota. So this becomes 4 times x minus 2 iota, or x1 minus 2 iota, then x2 minus 2 iota, then x3 minus 2 iota, then x4 minus 2 iota is equal to, this will be 4 into 16, so 64, then minus 64 iota, then this will be plus 68, and then it will be minus 24 iota plus 9. So this becomes 141 minus 88 iota. So here we got this expression. Now here are two approaches. Let's say that JEE aspirant 1, he or she is following approach 1. In this case, he or she takes modulus both sides and squares the both side of this expression. He or she gets 16 times modulus of x1 minus 2 iota square, then modulus of x2 minus 2 iota square, then modulus of x3 minus 2 iota square, then x4 minus 2 iota square is equal to modulus of 141 minus 88 iota square. Now here he or she writes this as x1 square plus 4, then x2 square plus 4, then x3 square plus 4 times x4 square plus 4 times 16. So this will be 1 by 16 into modulus of this. If you calculate, this becomes 144 square plus 88 square. So overall the whole expression becomes 125 over 16 m as stated in the question. So if you calculate from this, the value of m comes out to be 221. Now let us discuss about a second approach. Approach 2. It is followed by JEE aspirant, let's say 2. So he or she puts x equal to minus 2 iota in the initial expression. So he or she gets 4 times x1 plus 2 iota, then x2 plus 2 iota, then x3 plus 2 iota, then x4 plus 2 iota equal to similar as 141 plus 88 iota. Then he multiplies this equation 1 and equation 2. So from this he or she gets 16 times. If we multiply equation 1 and equation 2, we get the same expression, which is equal to 141 square plus 88 square. And if we divide this by 16, we get our required expression. So it is equal to 125 m divided by 16. So from here also the m value comes out to be 221. Now the main question, the conceptual part of this problem that I want you to answer in the comments is, which approach is wrong and why? Pause this video right now and post your answer in the comments. Now let us discuss which approach is wrong and why. The answer is the first approach is completely wrong. Now the question is, why? In the first approach, we use this step. We had x minus 2y, x2 minus 2i, then x3 minus 2i, then x4 minus 2i times 4 equal to, it was 141 minus 88 iota. Now when we took the modulus of both sides, the modulus of a complex number z equal to, let's say, real part of z plus imaginary part of z times iota is calculated as real part of z square plus imaginary part of z square. So when we took the modulus both sides, we actually calculated this modulus incorrectly, because it was not given to us in the question whether this x1, x2, x3 and x4 are real or complex. That means the equation that we discussed here, this equation may have some complex roots also. That means we assume the roots in this form. XR equal to alpha R plus iota times beta R for R equal to 1, 2, 3 and 4. These are the roots of this equation. So that means here this expression, let's say we take a general expression for all of these terms xr minus 2 iota. This expression will become alpha r plus iota beta r minus 2 iota, which finally becomes alpha r plus beta r minus 2 iota. So if the roots of this equation are complex numbers, then we cannot say directly that modulus of xr minus 2 iota is equal to xr square plus 4. This we cannot tell in general, because modulus of xr minus 2 iota, when we take the modulus both side here, we get it is equal to, by the way, there will be under root here, and the modulus of xr minus 2 iota will be root under alpha r square plus beta r minus 2 whole square. So we can only tell that these two are equal only when beta r equal to 0. That means the roots of this polynomial equation are real, but it was not given to us that these 4 roots are real roots. If it was mentioned in the question that x1, x2, x3 and x4 are real roots of this equation, then this first approach would have been absolutely correct. But in this case, this is not a correct approach. This is a very conceptual point that you have to keep in mind, because the answer by both the approaches comes out to be the same, which is m equal to 221. But the first approach is conceptually incorrect. I hope you understood the conceptual mistake that would have happened to you while solving this question.